The open-source community has published over 56,804 autonomous agent skills. Yet, developers can practically install fewer than 30 at a time. The bottleneck comes from a borrowed concept. AI engineers are treating language models like operating systems, relying on the traditional :install command to import tools into their workspaces. When you run :install, the system takes a 50 to 280 token YAML description of that skill and permanently pastes it into the agent's system prompt. If a developer loads a standard library of 50 skills, that creates a permanent, unyielding tax of over 7,500 tokens on every single turn of the conversation. By blindly copying the operating system package management model, developers are actively eroding an agent's reasoning capacity in the attempt to give it more capabilities. In a transformer model, the context window functions as an active compute budget, directly governing the quality of the agent's reasoning. When we load dozens of YAML skill descriptions, the developer's actual prompt is shoved to the bottom edge. This lost-in-the-middle phenomenon siphons mathematical attention weight from crucial constraints. Cluttered prompts cause fuzzy semantic matching, mistakenly invoking deployment scripts due to overlapping keywords. @Skills provides the architectural framework to bypass this bottleneck, allowing agents to reference tens of thousands of skills without a permanent token tax. Fixing the attention crisis requires abandoning the monolithic installation model and analyzing its component parts. This visual represents traditional installation, a single command that bundles three completely distinct operations. @Skills introduces functional unbundling. It separates the process into three distinct data streams: content, persistence, and auto-triggering. First, the content function handles the downloading of procedural guides, reference manuals, and executable helper scripts over the network. Next, the persistence function saves and version controls these files locally within a .at skills directory. Finally, auto-triggering is the act of permanently mounting front matter metadata into the system prompt, so the model can route tasks autonomously. When you isolate these streams, a clear optimization emerges. Only auto-triggering requires space in the system prompt. Content and persistence can live entirely outside the model's active attention. By disentangling auto-triggering from storage, the @Skills protocol categorizes skills into a new three-tier delivery taxonomy optimized for token spend. This sorting matrix evaluates every skill based on its token footprint and required availability. Tier 3 is the installed tier. It is strictly reserved for fewer than 10 critical always-on guardrails like security filters or JSON schemas. These still consume 50 to 280 tokens each in the system prompt. Tier 2 is the saved tier, comprising 10 to 30 project-specific workflows, such as local test scripts. These are Git-tracked for IDE autocomplete, but cost 0 tokens at rest. Tier 1 is the reference tier. This holds the vast, long-tail ecosystem of over 56,000 specialized tools and API guides. These live on GitHub and also cost 0 prompt tokens at rest. Moving 99% of all available skills into Tier 1 removes the artificial ceiling on agent capability. Developers can scale an agent's knowledge without bloating the system prompt. If 56,000 Tier 1 skills are completely absent from the system prompt, how does the agent know how to use them? The answer is dynamic user turn injection. The developer explicitly references a skill's URI in their prompt, causing the client to fetch and append the instructions for that single conversation turn only. This comparison contrasts the two delivery positions. On the left, instructions sit permanently at the top of a tall system prompt column. On the right, the @Skills protocol injects the instructions precisely next to the user's input at the bottom. We can map this directly to transformer math. By placing procedural instructions directly adjacent to the user prompt, the softmax probability mass for those specific constraints spikes to maximum strength. In the very next conversation turn, the injected skill is dropped from the active context, reverting its token cost back to 0. Dynamic injection completely eliminates residual context pollution. A deployment tool used in turn 2 will never cause false positives or style leaks in turn 10. For dynamic injection to function, the agent requires a deterministic addressing system to locate these skills instantly. This is the standardized @Skills URI grammar. It uses distinctly color-coded prefix and path elements to isolate namespaces and define the exact resolution route. The protocol defines specific routing prefixes. GH directs the system to a GitHub repository, local points to the current workspace, and sub targets nested reference manuals without loading the entire parent skill. Dynamically downloading and executing remote scripts from GitHub introduces massive supply chain attack vulnerabilities. This flowchart tracks the defense mechanism, a local validating cache. This layer intercepts all remote fetches to verify file integrity before execution. On the first download, the system generates and pins a full SHA-256-byte hash. On any subsequent run, it resolves instantly to the local cache, verifying that hash in sub-milliseconds. If a malicious actor alters a script upstream without publishing a version bump, the SHA-256 verification will fail locally, ensuring absolute tamper-proof execution security. Ultimately, this modular architecture moves the entire field of software engineering away from monolithic installs and toward dynamic, on-demand linking. This split-screen visualization tracks the economic outcomes of the two paradigms over a long-running developer session. On the left, static installation guarantees accelerated context exhaustion, forcing premature conversation truncation and memory loss. On the right, the @skills model maintains a 90% reduction in static token overhead, characterized by brief spikes at specific user turns that quickly return to baseline. Preserving the language model's attention budget exclusively for actual code-based logic and conversation is the prerequisite for advanced reasoning. This architecture also democratizes the global open-source community by removing the barrier of centralized package registries. Because explicit URI routing bypasses the need for gatekeeper approval, any specialized team can publish their workflows directly to their own repositories for immediate use. The @skills protocol turns every public repository on the internet into an instantly executable, zero-overhead extension of the AI's mind.